Hello, my name is not Pavel Stavianco and I will not show you how to sort elements
In a CubeGUI.
in a CubeGUI.
Good.
So we are back to our terminal and we start a cube file and we open an example of cube file. In this case that is the benchmark BTMZ, and the CubeGUI presents us as usual dimensions of this cube file or any cube file, metric tree, call tree and system tree. And today we would like to see sorting capabilities of CubeGUI. So basically how one can sort elements in a tree and how one simplifies when it simplifies analysis of performance data. So first of all, sorting one finds in a context menu. One presses a right mouse button and goes down and sees sort tree items. And the submenu is open and various modes are available. So sort by name, that's probably the most obvious way of sorting. Sort by inclusive value, apply now. So what is the difference I will explain in a minute. Sort by exclusive value, apply now, and sort by order of definition. And we see that order of definition is the default sequence of or default sorting modus. This sorting of tree items as a feature is available in every tree, in every dimension, but maybe only in a flat tree it is most useful tool. In a metric tree it is probably least useful tool, simply due to the fact that we have different metrics, they have different units of measurement and therefore also different scope. So for example here MPI bytes transferred, we are dealing here with milliards of bytes, and time, for example, these are seconds, so we have here only 300. So obviously sorting of elements on this level doesn't make much sense, simply because milliards are huge and definitely larger than seconds, but nobody compares bytes and seconds. One could probably think that sorting within a metric hierarchy makes sense and simplifies life a little bit. Not really, simply because the hierarchy of the metrics is never so large that sorting really improves display. There are only few children of metrics. They are usually disjunct, and therefore one can compare them relatively easily at glance without big difficulties. So therefore this feature being rarely to never used in the metric tree. In system tree it might be useful, simply like for example if we open expand a little bit system tree and then we select let's say sort by inclusive value, then the rank which has highest value of course will be displayed as the first one. But first means only that it has highest value, but it has nothing anymore to do with its number of its rank, and so in this case we see that it's 2, 6, 4, 5, 1. So correlation with the actual job is kind of lost. If one would like to see the correlation between rank, performance data, and physical location on the system, it's one should use the topologies plugin, and I will explain how to use it in one of the future videos. So in a call tree, the sorting of elements might make sense because call tree can be large, but here one has to keep in mind following. Sorting happens always on one level, like for example on this level. So if I use here for example sorting by inclusive value, the largest value jumps as the first, and the next large and the next large and so on. But if I expand, for example, this exchange QVC, then I see that this level gets its own sorting. And here, for example, copy X phase has smaller value than MPI setup. And again, if one expands call tree, let's say, deep enough, the sorting will be not anymore visible, and it is hard to interpret the call tree. What do I mean with hard to interpret of the call tree? This sorting order by definition has a relationship to the execution of the program. So the score P defines every region and every call path when it meets it first time. So here we see that the execution goes into main, then it goes into MPI setup. So the score P creates the child MPI setup, then it goes deeper. There is a call MPI init, then MPI com size, ranked split, and exactly in this sequence, these calls are performed, maybe in a loop, but first execution happens in this sequence, and score P also defines them in this sequence. Then it leaves, for example, this MPI setup and goes perform some MPI broadcast, and then that goes into environment setup. Obviously, this MPI broadcast was needed just to broadcast exactly this environment, and so on and so on. So the order of definition has a relationship to the execution of the program, and therefore it is kind of useful. If one changes it, and for example sort by name, then the fact that MPI barrier is before MPI broadcast is simply due to BA and BC and nothing else. So this sorting is then least useful. One might think in this way I can find a region easily, but we see that here is MPI broadcast, here is a copy. So if the call tree is expanded deep enough, then again the sorting is mixed, and the argument that it is easy to find some call path is not valid anymore. For that, it is better to use finding functionality, which I explained in one of the previous videos. So, the most useful sorting happens or is being used in a flat tree. Flat tree is a list of regions, it's not a call path, not call tree. So here is every region is listed separately, and the data that's aggregated data to this region. So despite of how many times it was visited, for example, time or any another metric, aggregated across all these visits and executions. So here, of course, the sorting makes sense. So because, for example, if we go and we would like to see the region which spent in which execution spent largest or most time. So in our case, that is the time metric. So we go and we select. So we sort by inclusive value. So let's do apply now. So I selected apply now, and I sorted all this data by inclusive value. If we take a look, so obviously here is BTMZ, that's all application has a largest value, then the main, then ADI, then this ZSolve, and so on. So here is of course the regions which are on the top of call tree are naturally on the top of the sorting, because that's sorting by inclusive value, so it is together with all subsequent calls. We used apply now, the command, so that performs a single shot of sorting. So I sorted out this data. So now it is, as we see, in very, very short fashion. And if we select now another metric, like for example visits, we see that the sequence has state, but the data is not sorted anymore. So that is useful if one would like to see maybe correlation between two metrics. That's one of the way to do it. Or one doesn't want to destroy the sorting, maybe because we have here the regions are sorted, they were close to each other. So if we take another metric, the cost for example, we can see they are together but in this list, but their value are not anymore really similar. If we select not apply now, so a single shot, but we select this sort by inclusive value, that is we select the display modus, it will be always sorted by inclusive value. So if we change the metric, it performs sorting again for this metric. If we go on visits, it performs the sorting, and we see that, for example, the largest number of visits and all subsequent calls is of course VTNC, that's our application, then top call, and then the ADI, that is our main region, and so on and so on. And in this way we know that largest values will be on top, so by selecting simply metric, we don't need to scroll in a flat tree anymore. In the search of the largest value, it will be on top. Difference between inclusive and exclusive value we explain always in our tutorials of performance analysis. I will not explain it here, but if we demonstrate, if we just select here, for example, exclusive value, we see that the on the top are not anymore main or another calls, but OMP do Z-solve, Y-solve, and X-solve, and obviously these are regions which exclusive value has largest, exclusive value is the largest, and therefore these are the best candidates for optimization, and not like for example main, because main itself has the smallest execution value. It's all subsequent calls which contribute to its value. So that is how sorting might help in analysis, simply because if we set a sorting modus, like for example here, and we explore and browse metric tree, then our most interesting regions will be automatically on top. Another useful method or useful usage, that's not lucky, of sorting is together with plugin Scorpion, which is dedicated to filter creation within CubeGUI. This plugin I will explain in a future video, so stay tuned, subscribe, give us a like and comment, and see you next time. Thank you very much.